Hey, what's up, ladies and gentlemen? My name is Keith Jacobs, STEM specialist with Illinois 4-H. It's another Beautiful Maker Monday, and today we will be making a Baby Yoda flying drone carriage that flies and is a drone and has Baby Yoda in it. It was really important for us to reuse stuff that we had lying around or weren't using anymore. So for this build, we're repurposing this racing drone to go right into the baby carriage and act as its power system. For this project, you're only going to need paper, some foam board, hot glue with glue sticks of course, and tape. Pencils, papers, as well as scissors, basic things. But this is a pretty simple project, and we're going to guide you step by step on how to make this project, as well as how to use the software required to design this. With that being said, let's get started. To start with, I know the Mandalorian is about 6 feet tall. Using that as a reference, I sketched out Baby Yoda to scale in order to estimate his height. Based on the scale drawings, we estimated him to be about 16 inches tall, which then would make his crib, adjusting for extra headroom, about 20 to 22 inches or so. This is perfect, as the foam sheets we'll be using for this project are about 20 inches wide. This gives us a good reference point to start with when designing our crib in the free cloud-based 3D design tool Tinkercad. Upon opening Tinkercad, I decided to set the parameters for my project. Because I know the crib is egg-shaped and will be about 20 inches high, I know it will be equally wide and slightly longer than 20 inches. So I set my work grid to 40 by 50, remembering to specify the units. Next, from the right, I imported a sphere and adjusted it to the dimensions I wanted, keeping in mind the sketch. I then imported a box and lined it up where I wanted the crib's opening. Then I changed the box from a solid to a hole and merged the two, leaving the crib shape I wanted. Then, knowing the dimensions of the drone I planned on using, I modeled it up in 3 dimensions, making sure to account for the props and the motor tips. Once those dimensions were modeled, I converted the shape to a box and accounted for all the space needed for the drone to fit within the crib. I made the box about a ½ inch larger in all directions to account for any error in my design. This box will give me the shape I need to later design and laser cut the frame. I then took the shape, lined it up with the crib, and turned it into a hole that would perfectly fit our drone. I used the same method to create a sunscreen on the upper portion of the crib. Then I saved and exported my design as a STL file. Then, using the dimensions from the box we previously cut into our crib to fit our drone, I designed a frame that would be strong and lightweight. I used Fusion 360 for this. However, any program that lets you draw or design using custom dimensions and export your design in the format required by that specific laser will work just fine. As long as the frame can hold your motors and equipment, it can be made out of anything, even cardboard or wood. After I was happy with my design, I sent it to our laser to be cut out of draft board. Like the frame, the crib needs to be lightweight and allow air to pass from the top to the bottom. So I opened a free tool called Slicer in order to convert my 3D model into 2D patterns that can be cut out of foam board. I imported my design and specified the dimensions of my object and the size of the materials I'd be using. Then I selected interlock slices from the slice distribution and adjusted for the number of slices I wanted for each axis. If you don't like the way the design looks, you can easily modify the direction or angle or even the specific placement of each individual slice. Once I was happy with the design, I was able to view each slice and even instructions on how to build it out. You can print out or laser cut these templates, but what I did was trace them onto paper using my office TV. This was quick and easy and required no fancy tools or equipment. Once I was done, I was left with 12 sheets of paper and 16 parts to transfer to our foam board. Alright, so after spending about an hour and a half tracing our templates onto these pieces of paper, what we're going to do is actually transfer these directly to the foam board. So we're going to put the foam board right under this and cut these out using a razor. One of the things we're going to pay close attention to are our lines. See, when I drew it out, some of the lines aren't perfectly straight, but as long as we use a razor, a ruler, when we're actually going over these lines, making sure that we are cutting out on the inside of these lines so that these voids aren't going to be so huge. We'll be able to actually squeeze the parts together and fit them a little bit better. As long as these holes are tight. We'd rather them be too small than too big. So let's get started on that. So what I did was lay out some cardboard to protect my table and gathered my 12 foam sheets. I then used tape to secure the template to both the cardboard and the foam board. I decided to cut this out with a box cutter, but quickly saw that the blade was dull, so I sanded it sharp with 80 and 120 grit sandpaper. Next, I simply followed the design template and smoothly traced out the design. Don't try to force the cuts all the way through the material, but rather trace over them gently, allowing for multiple passes if you need them. Once cut out, I carefully cleaned each piece and repeated these steps for the 11 remaining sheets. Now that I have each of the pieces cut out, what I'm going to do is go ahead and kind of dry fit them to make sure that everything fits properly. What I'm going to want to do is make sure that some of these edges that may have little pieces of foam in them or paper in them, I clear those things out and make sure that it fits. I'll be able to adjust it before I get completely done and ready to paint it and sand all these little things down. But dry fit will really let us know how well we did on our cut and how well the model actually worked. To dry fit these pieces, each of them are labeled, so I made sure to keep the labels that were in the actual slice document. That document also comes with instructions beyond just the blueprints. So we'll be able to use those instructions to put this whole thing together and hopefully get us a cradle. So, see how it goes. In the screen on the top right, you see that the slicer for Fusion 360 provides you with the assembly instructions, which are super straightforward and require very little effort on your part. As you can see, the final product mirrored our design. Once assembled, the crib was incredibly strong given its interlock design. Even so, Eric reinforces the thinner pieces with hot glue and duct tape. Next, we had to weigh out our part to be sure it was light enough for our drone to carry with the battery and new frame. We found that the weight was exactly 1 pound, which was incredibly light for its size. We also found the center of gravity for the frame from the front to the back, which will allow us to balance out our drone when it's hovering. Alright, so now that we got this guy cut out, we have our frame actually ready to sit right in here. What we're going to do is take the contents of this racing drone and put them onto this frame. Like I said, this frame's a lot lighter than this whole body here, and will actually provide it enough stability to be able to fly in this guy because we're not going to be sending it down any racing tracks or anything like that. So let's go ahead and get started just deassembling this guy and reassembling it on here. We'll use a couple tricks to make sure that all the holes fit properly in our cutout that we did, because we didn't actually drill the holes or have the holes laser cut for each of the screws. We just want a little bit of flexibility in that. But because all the motors are the same, once we make a little template, we'll be able to use it perfectly for this guy and get everything out of here onto there in a much lighter form factor. So let's get that started, guys. Okay, so I started this off by taking out each of the screws I knew were connected directly to the frame, then moved on to the screws I couldn't tell what they were connected to. This will vary for your specific drone, but most schematics can be found online with a quick Google search. To make the holes for the motors, I traced the holes from the original frame directly onto our new frame, which worked perfectly. I then reassembled the drone onto the new frame with screws and electrical tape. I also extended the FPV wires to accommodate for our frame length, using a solder iron and solder. Hey, what's up guys? So after a long weekend and a little bit of time to be able to check this guy out and test out some of the settings on it, I found that the board that we were using was corrupted and it just stopped working. It wasn't booting any of the firmware, it wasn't allowing us to load any of the firmware, and because it was an older board, we decided that we're just not going to use that. So I grabbed an old CC3D board, which has a firmware on it and a system called OpenPilot. And OpenPilot was developed a while ago. It was an open source flight controller and a system that was developed some time ago by a bunch of people in the DIY community. But unfortunately, that has since been disconnected, maybe even a couple years ago. So I just had this guy sitting around for a while. I used a different firmware called OpenLibre, which is basically a continuation of the OpenPilot project. But as you see, while I'm controlling and moving this guy around, you get live telemetry data coming through USB right to our computer from this flight controller. So everything is working out. I wasn't even able to connect the old flight controller to the computer. So what I did, instead of redoing this whole system, and like I mentioned before, I didn't want to completely rebuild the drone. I wanted to use something we already had. I just kind of rewired some of the stuff. So instead of having, for example, the ESCs go directly to this flight controller, the NAS 30 or the NAS 32, I have it going directly to the OpenPilot flight controller here. The receiver, I was able to just plug and play, take it right out of this flight controller, put it here. I left all of the power distribution board and everything like that still connected. That way we could still get power to the to both the receiver, or excuse me, both the video transmitter, as well as the camera, the LED lights, all that type of stuff. It's running a little bit more than it typically is used to, but it's gonna work. I'm pretty confident it'll work. So hopefully we get this up and running, finish calibrating this guy out, and get this thing into our cradle. So thanks. So right now we just really want to test fit this guy. At this point you could see kind of how we have it all set up. We have the camera up here in front, the wires from the camera going to the back to the video receiver, and we have this little transmitter to the antenna to the transmitter, the video transmitter. Right below that we have the Spectrum satellite receiver. We also have our CC3D board there, as well as the other board that came with our original copter, as well as the power distribution board, the ESCs, everything taped down there. Our battery will plug in there. We have all of the propellers on, the right configuration and everything. And now all we got to do is figure out what the center of gravity is of this whole thing. When we started, we made sure that the center of gravity of the frame was right about the center of gravity of the quad frame. Now all we have to do with some of these added components, some of the stuff spaced out, is just figure out what that is. That way we put the battery to offset it in the perfect location. So let's do that. Alright, so this is like take 5 or 6 or something, but yesterday we weren't able to get it completely off the ground. I need to balance some stuff out. But what we're gonna do today, I switched the battery that we're using. Before we were using a 3-cell or 3S battery. Today I upped that power to a 4S battery, which will give our little racing drone a lot more power and hopefully more thrust to get this guy off the ground. I checked it out yesterday just to see if it'd get off, and it kind of bounced a little bit, but we're gonna check it out now. Unfortunately, the room we're gonna use is completely occupied, but on this table, because it's pretty much flat and even, we'll be able to see how it drifts and which way to put maybe some counterweights, maybe some pennies or nickels or something like that, to just give it a more center of gravity balance. So let's see, let's arm this guy. Alright, sounds pretty good to me. It's gonna fly. Oh yeah, we're good to go. Okay, so the last thing to do before we were able to Maiden our baby Yoda crib was to paint it. To do this, I started off by masking off all the drone components with plastic. Usually I just take the drone out, but we were building on a time budget and this method worked just fine. Using different color spray paints, I lightly applied each color one layer at a time until I got the desired results. We allowed the paint to dry for about an hour, and while this was drying, Eric cut out and decorated our baby Yoda. Per usual, we were going for the feel rather than the exact look, and the results were pretty dope. So great, we're finally here. As I mentioned before, we finally have the finished product. the little baby Yoda carriage all done, ready to go. I was gonna put on the whole Mandalorian armor, but I think this will suffice just to make sure that this guy can kind of fly a little bit. So hopefully it'll work, and yeah, we'll see how that goes. All right. Okay, baby Yoda, test. So before taking it out for its maiden flight, we tested it, then retested it, then tested it again until we accepted that it was not gonna fly like our typical scratch-built drone. And overall, we were pretty okay with that. Okay. All right. Yep, I can see. Oh. It's a little sketch though. Okay.
Mounted it inside the helmet.
It does look really cool though.
I mean, it looks a lot like one of the clone trooper helmet variants.
All right, here we go. Here we go. All right, so this is Yoda's first real flight. Little baby Yoda's first real flight. It's a yaw problem. There it is. And after several awkward flight attempts, I decided to go full throttle with what was ultimately our best shot. Literally the very next run, the battery rips out, damaging the frame and the support of the whole carriage, just ruining it. And baby Yoda's flying days were over.
Battery.
Yeah, battery. I know, I just saw it going that way. So yes, thank you so much. This guy actually does fly. I see that we have a little bit of a yaw problem, but that's something that we can definitely overcome and get right. We had the battery pop out at the end, but as you see, it's definitely powerful enough to get off the ground and get up and gone. So yeah, thanks a lot, and keep watching our videos, subscribe to our channel, and check out our Instagram and Twitter. Thanks.
Bonus footage activated.